Hello students, today we are going to discuss how to generate an amplitude modulated wave. We have already learned the expression for amplitude modulated wave. We already learned what is an amplitude modulation, etc. Right? So now let's see how we are generating amplitude modulation. Because when we were discussing about the modulation and its different types, we have already learned there are three main types of modulation, that is frequency modulation, phase modulation and amplitude modulation. As our syllabus is just about amplitude modulation, we are going to discuss only about amplitude modulation. So let's understand how to generate amplitude modulation. So this M of t, do you remember what is M of t? M of t is nothing but the modulating signal and the carrier signal is getting added with the adder. So when this M of t and C of t is getting added, we will be getting our output X of t. So X of t will be what? M of t plus C of t, right? About the derivation part or the equation part we'll discuss first. Let's understand how to generate amplitude modulated wave with the help of a block diagram. So I'm just saying the equation. Once I complete this, I'll explain about the equations. So M of t and C of t is getting added with the adder. We'll be getting the input which is X of t. The output of X of t is what? Is nothing but M of t plus C of t. Then this X of t is given to a square law device. This square law device is nothing but it is a device which will be adding. What is modulation? We are superimposing the high frequency wave with a low frequency wave. So obviously the strength of the information is getting added, is getting increased. So when this X of t is given to a square law device, we will be increasing the strength so that we can carry it to a very long distance, right? So once this X of t is given to a square law device, then the output what we are getting is Y of t, which is Bx of t plus Cx squared of t. Then we will be giving that to a band pass filter, because our signal which we want to reach at the receiver end is M of t. Though it was not having enough strength to reach the receiver end, we are adding a carrier signal with the modulating signal with the help of our adder, right? Then we will be getting a output X of t, which will be the input of a square law device. Altogether the strength of the signal has become very large, right? So once after coming out from the square law device, before making the amplitude modulated wave which we have to carry for a longer distance, we have to pass it through another device which is called a band pass filter. Here in band pass filter, what they are doing is, they will be allowing only those signal which is necessary to carry the information to a longer distance. From there, we will be getting the amplitude modulated wave. So basically this is the block diagram wherein how we create or how we generate an amplitude modulated wave. So I'll repeat one more time. Our input modulated wave is getting added with a carrier signal by using an adder. We will be getting our input X of t, which is again the input of a square law device. So square law device will be squaring, in fact we can say will be squaring the strength of the signal, which is given as Bx of t plus Cx squared of t. This is again given to a band pass filter, wherein that device will be deciding what all frequencies should go to the receiver end, wherein will be this band pass filter will be deciding what will be the amplitude modulated wave, what will be the strength of the amplitude modulated wave, or how much the signal, the information signal should get modulated to reach the receiver end. So now let's understand this by using equations, or let's find out an expression. So students, now we have learned how to generate an amplitude modulated wave with the help of a block diagram. As we have already discussed and derived an expression for amplitude modulated wave, let's understand how it is getting generated by using equations as well, right? So we have already learned the modulated wave, the equation or the expression for the modulated wave is An sin omega mt, right? And expression for the carrier signal is AC sin omega ct. After that, what is happening? This modulated signal is getting added with the carrier signal by giving an output X of t. So X of t can be represented as M of t plus C of t. right? Which means we will be getting an sine omega mt plus ac sine omega ct, right? So now after this input we are giving it to a square law device, wherein we will be getting another output which becomes the input for band pass filter, that is y of t. Y of t is equal to what? Y of t is equal to bx of t plus cx squared of t, right? Where this b and c is nothing but a constant. Nothing is going to happen with this b and c, because they are constant. Once it passes through the band pass filter, it will be getting removed. Okay. So y of t is bx of t plus cx squared of t. So now what we have to do is we have to substitute the value of bx of t and cx squared of t, right? So y of t will be equal to b into the value of x of t is an sine omega mt plus ac sine omega ct, that is bam sine omega mt plus ac sine omega ct. Y of t is b plus c bx of t plus cx squared of t, which will be plus c into an sine omega mt plus ac sine omega ct the whole squared, right? It is ac sine omega ct the whole squared. Now we know it is in the form a plus b the whole squared, right? So now when we are rearranging this equation, we will be getting ban sine omega mt plus bac sine omega ct plus a plus b the whole squared is a squared plus b squared plus 2ab, right? That is c into a squared, that is am squared sine squared omega mt plus ac squared sine squared omega ct plus 2am into ac sine omega mt into sine omega ct, right? So after substituting all the values, we got y of t as what? ban sine omega mt plus bac sine omega ct plus am squared sine squared omega mt plus ac squared sine squared omega ct plus 2am ac sine omega mt into sine omega ct. So now it is in a very it's very hard to remember, right, after substituting all these things. So what we have to do is, by substituting the trigonometrical values, we can simplify it, right? So the equation which we are having now is y of t is equal to bam sine omega mt plus bac sine omega ct plus am squared sine squared omega t plus ac squared sine squared omega ct plus 2am ac sine omega mt plus sine omega ct. Now it's our duty to simplify it by using trigonometrical equations. So if we go through this, it is in we can solve this by, it is in sine squared a form, right? So which is 1 minus cos 2a by 2, as well as here it is 2 sine a sine b form. So here also we can write cos a minus b minus cos a plus b form, right? So when we are simplifying by substituting those trigonometrical equations, we will be getting y of t as y of t is equal to bam sine omega mt plus bac sine omega ct, which was already there, plus c by 2 a squared m plus ac squared minus c a squared am squared by 2 cos 2 omega mt minus c ac squared by 2 cos 2 omega ct plus c ac am cos omega c minus omega m into t minus c am ac cos omega c plus omega t. That is the equation. This is how we will be getting, or we will be able to generate a amplitude modulated wave. If we understood the derivation, it is very simple. So I'll repeat it one more time. First what we have to do is just remember this block diagram. We know the equation for modulated wave, which is Am sin omega mt. We know the equation for C of t, which is AC sin omega ct. When we are adding these two, we will be getting x of t, which is Am sin omega mt plus AC sin omega ct, right? Then that is going to a square law device wherein we will be getting y of t, which is equal to Vx of t plus Cx squared of t, where b and c are constant. When we are substituting the value of x of t and c of t, what will be there? We will be getting Bam sin omega mt plus Bac sin omega ct. There is no need to derive it. Just remember through the block diagram. It is very easy. Bam sin omega mt plus Bac sin omega ct plus C a squared m sin squared omega t plus C AC squared sin squared omega ct plus 2am, because here it will be in the form of a plus b the whole squared, right? Plus 2am AC sin omega ct into sin omega mt. Now in order to rearrange, we will be substituting the trigonometrical equation. Then when we are substituting the trigonometrical equation, we will be getting the final wave, final amplitude modulated wave, which is going through the band pass filter, will be this much. Once it enters the band pass filter, it will be removing all those unwanted frequencies, right? Which is not necessary to carry the modulating signal. That will be getting removed and our amplitude modulated wave will be generated, right? There will be getting the final expression which we are derived when we are learning about expression for amplitude modulated wave, right? Okay.